Okay. So we have seen how the basic definitions for moments about arbitrary point and moments about moments about the mean and moments about arbitrary point. Now, there's one more way in which you can remember both of them. That is finding the relationship between both of them. If you can find a relation between moments about mean and moments about arbitrary point, then our job will be easy. Let's see that in this video. Relation between, relation, of course, relationship between moments about mean in terms of arbitrary point. About mean in terms of arbitrary point. Okay? Yeah. Now, what is the moment about mean is mu r. Mu suffix r would be 1 by n summation fi xi minus, here it would have been a if it is arbitrary point, but otherwise it is x bar power r. Okay. Now what you do is you add and subtract a, because I want to find the relation between mean and arbitrary point now. So what you do is you add and we will add and subtract a. Okay. So minus a plus a minus x bar power r. Okay. Yeah. This is equal to 1 by n summation fi. Of course, fi is there, f suffix I. xi minus a, I have denoted it by di. If you see my previous video, it will be there. A minus x bar power r. Okay. Separate them. Separate them. Or what I will do is this one. X bar minus a. If you, I've done in the previous video. Anyways, I'll just scroll up just to show you. X bar minus a is nothing but mu r prime. That's the reason I have inserted a. See this one. This one is nothing but x bar minus a is mu 1, mu r, no, mu 1 prime. Okay. So the same thing I will insert here. What that is it is a minus x bar. So it will come with a minus sign. What that is 1 by n summation fi di minus mu 1 prime whole power r. Okay. Now you can see that this is nothing but the power r is there. Now I can go with a binomial expansion. Na? Something like x plus y or x minus y binomial expansion. How does it sound? Just see. I will write it clearly here. X minus y whole power n. How do I write it? NC0. Okay. X power 0 or anything. X power n, y power 0. Either ways I can take. Okay. X power n, y power 0 minus, because y has a negative sign, NC1, x power n minus 1, y power 1 plus. Alternative plus minus signs I will have. NC2, x power n minus 2, y power 2. Okay. Minus and so on it goes on. How will it go is minus 1 power n will be there, or minus 1 power n will be there. NCn y power n. Till there it will go on. Using the same formula, I'll be rewriting the above di minus mu 1 prime power r. Okay. Similar formula, and all of you know the binomial expansion, right? Yeah. So what will I get it is 1 by n summation fi. Okay, summation fi is outside. RC0 di power r. Of course, mu 1 prime power 0. So it is 1. I'm not writing it. RC1 di power n minus 1 mu 1 prime power 1 plus RC2 di power n minus 2 mu 1 prime whole squared plus, I'll write one more and probably I can stop. RC3 di power n minus 3 mu 1 prime power 3, and it goes on and on. Of course, plus minus plus, and this should be a minus. This should be a minus and next it would be plus. For all even values, it is plus. For all even powers of mu1 prime, it is plus. For all odd powers of mu1 prime, it is minus because mu1 has a minus sign in front. Otherwise, all will be plus for binomial expansion, right? Now, let me separate the terms. RC 0, this is. Okay, let me separate all the terms. Let's see what happens. 1 by n is there. RC 0, summation Fi, di power r by n minus RC 1, mu1 prime is also there, which is again a, which doesn't have anything to do with I. Okay, yeah. So, Fi di power, this is r by the way. There in the above formula I had n, here I have r. So, it is r. Right? So, di power r minus 1 by n, and it goes on and on. Right? You are understanding the rhythm. Right? Yeah. So, this would be what? Mu r. On the left hand side, I have mu r. This is equal to RC0. Okay. This is nothing but a mu r prime. I can just show you. I can just scroll above and show. This is nothing but RC1 into mu1 prime is anyways there. This is what? Mu r minus 1 prime. Okay. Yeah. So, and it goes on and on. Because of the space, I'm just skipping off the remaining term because the same rhythm follows, right? Yeah. Of course, here for the last term, probably, what can happen? Minus 1 power r. RCR is 1. Mu1 prime power r will be there. Summation Fi by n will be there. This value will come to be 1. Okay? Yeah. So, I'll be left with last term. What will be there is minus 1 power r. Okay, RCR mu1 prime power r. Okay, this is what I will have. Now, accordingly, I'll be substituting r is equal to 2, because already I have for 0 and 1, right? For 2, what will it be? You can just see. Put r is equal to 2. What happens? R is equal to 2. Mu 2 will be what? 2C0. 2C0 mu 2 prime minus 2C1 mu 1 prime mu 1 prime plus 2C2 mu 1 prime whole square. Okay. So, this would look like this. 2C0 is 1 only. And then 2C1 is 2 only. So, mu 1 prime squared plus 2C2 is 1 mu 1 prime whole square. This is what is mu 2. Okay. Similarly, for r is equal to 3 and r is equal to 4 also, I can write relationship between moments about mean and moments about arbitrary point. Mu is equal to 3, simple. I'll put r is equal to 3 in the above formula. Mu 3 will be what? Basically, guys, these would be your binomial coefficients only. 1, 2, 1. And next what I'll have? 3, 3, 1, 1. Okay, you can just observe. Of course, if there is a simplification, then one of the 3 will vanish off and become 2 because there'll be a small simplification for the next terms. 3C0 mu 3 prime minus 3C1 mu 1 prime mu 2 prime plus 3C2, okay, mu 1 prime squared mu 1 prime squared mu 1 prime. Okay, yeah. 3ab square, 3a square b kind. Okay, 3c2, then 3c3 mu 1 prime whole cube is what I will have. Yeah, you just observe here. 3c0 is 1, mu 3 prime minus 3 mu 1 prime mu 2 prime plus 3c2 will be what? 3. Okay, 3 into 2 by 2 into 1, 2 gets cancelled. So, it is 3. Mu 1 prime square, mu 1 prime. Okay. Minus mu 1 prime whole cube. Okay. Anything common, if it is there, you can just cancel out. Okay. So, this is what? Mu 1 prime whole square, mu 1 prime power 1. Mu 1 prime whole cube. Both are same only. Now, this is plus 3, this is minus 1, because of which 1, 3, 3, 1 coefficient vanishes off and 3 mu1 prime, mu2 prime plus this would give me what? 3 minus 1 would give me what? 2 mu1 prime whole cube. Okay. This is also mu1 prime whole cube only. Right? Yeah, this is how I will derive. Similarly, for mu4, r is equal to 4 also, it will come like that only. Just see, I can write easily with binomial coefficients. The thing that you need to observe is the below sum is also same. The whatever is the quotient, the below sum also will be the same. Or here I have 3, here I have 3, here also I have 3. Of course, power is there now, mu1, mu1, mu1. So 1 plus 1 plus 1 is 3, right? Yeah, mu4 you see, again the binomial quotient, 1, 4, 6, 4, 1, right? So mu4 prime 4 mu1 prime mu3 prime plus 6 mu1 squared mu1 prime squared, I'm sorry, mu1 prime squared mu2 prime minus 3 mu1 prime whole power 4. Okay, actually this would have been 4, but it has vanished off because of that 1 plus 1. Okay, now if you see the suffixes are all 4s only. Here square is there now. So again this is also 4 only. Right? Yeah, mu1 squared, this is, and this is mu2. So mu1 squared and 1 will be there. 1 plus 1 is 2. 2 plus 2 is 4. Again, this suffix 1 plus 1 plus 1 plus 1 is 4. Like that, you should be able to remember because these are very hectic, very tedious. Okay. So suffixes, superfixes, all those are difficult to remember. Even the coefficients are difficult to remember. So this is the way I should try to remember the, because these are the ones which will be used to decide the skewness and kurtosis. Bowley's, Karl-Pearson coefficient, deciding whether the curve is platokurtic, elliptokurtic, or mesokurtic. For all those things, the beta 1, beta 2, gamma 1, gamma 2, for all those things, moments play an important role. With this, I'll just stop this video, come up with different things in the next one. Probably a problem.